Okay, so we had to cut that in half, and we're on the quantum fluctuations, and we're talking about quantum physics, and we're going over. Right now, we're on a Forbes article. Let me back up real quick where we were on the last video. We have went over about how space-time talks. We have space-time talking to matter, matter talking to space-time, stuff appearing, disappearing. Somehow it knows, it feels. Space-time can know and feel. Somehow it's able to talk to matter. Matter is able to talk back. They communicate in some way, which is the mechanism there is not fully explained. We've gone over the lecture on astronomy. We've went over this whole thing. So we're moving on forward. We went over the model. The model, cartoon model, shows an edge of space. That there's something beyond space because there's an edge to space. And then we have, like I said, the quantum fluctuations, which by definition means having a point in time. Yet space did not exist before the quantum fluctuation, before the inflation. The inflation was started by the quantum fluctuation. So we can move forward. Okay. Oh, those are the quotes. We'll come to these in the end. You guys will see why he was saying what he was saying. Um, so let's go over what is the quantum fluctuation. There's a bunch of weird stuff. We already know. Okay, well, first of all, who invented this? You know the history of science. Like I said in the last video, or the video before the last video, where I talked about gravity. And I was on my break. So, you know, who invented this? Who invented this? We went over it. It was gravity was invented by Isaac Newton. He was totally insane. Einstein tried switching it up, and Einstein though was buddy buddy with, you could easily type this into Google or any search engine. Who invented the Big Bang Theory? It's George Lemaitre, George Lemaitre, George Lemaitre, George Lemaitre, George Lemaitre. Oh, look. Let's look at that photo. Let's see what that's about. Oh, there it is. He's telling him, like, dude, imagine in the future 10 billion humans will turn against socialism. And then Albert's like, oh, yeah, I see. If everyone gets smart, and he's like, yeah, duh. Like, mankind will fall apart because everyone will be smart. And he's like, oh, yeah, it's relative. You need smart people with dumb people to make relativity work. You can't have everyone being smart. So, anyways, that's just a little funny stuff I throw out there. That was all. That was so, that was something we could envision. We could just that was hypothetical. Okay, so yeah, it was George Lemaitre was the one that invented the Big Bang, and that he's the one that made up all this quantum fluctuation. Like, come on, let's be honest. Um, the Catholics are great at brainwashing humans, and imagine the Catholic Church trying to fight real life science. It's a losing battle. You can't win against science. You will lose. Real life science wins. The church had no choice but to infiltrate science, distort it, and twist it. Oh, like space time. So, quantum fluctuations, simple and clear explanation. So, okay, quantum mechanics suggests that empty space is actually vibrating with virtual particles. Let's go with that again. So we thought that vacuum is empty, but the reality is that vacuum is not entirely empty. That's a claim. I would like to see that. I would like to see that your mythical vacuum that's supposed to be empty is not really empty, and I want to see that edge. As we see right here in this cartoon, there's an edge. The matter and the mass inside is limited. It cannot move beyond this cube. Yeah. So that cartoon fails. Get off that. So, it says quantum mechanics suggests that empty space is actually vibrating with virtual particles. Quantum mechanics suggests that empty space is actually vibrating with the virtual. Suggesting virtual. Okay. These virtual particles come in reality and pop out of reality. You know, they pop in and out of existence. They appear and disappear. Totally ghostly. Like on the screen of the old black and white TV. Now, actually, that whole thing about the black and white TV is really trippy because we see our vision. Where it was like when we see that horizon, that flat horizon, and whatnot. When you turn on and off a black and white TV, you see that horizontal line and everything converging into that line. So that's pretty trippy. So you guys should look at that. And you know what? That's something that came from one of Tesla's inventions. Anyways, moving forward. Sorry, that was kind of sidetracking there. So what are quantum fluctuations? In this universe, every matter has equal and opposite antimatter. They have everything similar except their charges, like electron has positron, the neutrino has an antineutrino, the proton, antiproton, many more. When these antiparticles meet, they destroy themselves and release energy. Now, I like the whole duality ideology, but making claims that like the particles are like fighting each other. They're fighting themselves. They're like, oh, that's just my mirror image. Ah, and they go to battle and they kill each other. They're like, they totally annihilate each other. I would like really want to see this fight. Like I want to paste. I would like not only would want to see it, I would want to broadcast it. Okay, I would want to broadcast this fight. It would be like they're gonna destroy themselves. We're like woo woo woo. We throw them in a like, to the death. We throw give them one sword. They're like both of you will fight each other and throw one sword in there. Well, we'll do some like Saw, like the movie Saw, like Jigsaw. You know what I mean? Like we'll do one of his games. Like let's play a game. I would like to see like one of the particles be like, is there no one else? Okay, so let's move forward. So, moreover, according to the Heisenberg uncertainty principle, energy can never be zero, but it can be vary. The same concept applied here. So, there's a principle about, everything not even being certain. And it can never be zero, but it can vary. Like, maybe not, probably so. So that concept could be applied here as we read about the quantum fluctuations. And we know that energy is equivalent to mass. So where the rise in energy occurs, the probability of rising particles increase. And at the same time, antiparticles also form. Form how? That's like form, like, give us, like, these are really weird claims. What do you mean they're forming? Like, show us something how it's forming. Watching the human, human form is even weird as it is. The sperm cell hitting the egg cell, and then they get together, and then it starts like multiplying, or is it dividing? Wait, and that's weird enough. And so we're here. We are reading some weird quantum fluctuation stuff that no one's even ever seen. So again, they collide, destroy, and they further destroy themselves. This process again, again, and again, and again. The vacuum also further creates a fluctuation in the vacuum, which is known as a quantum fluctuation. So this is a vacuum. This is already the space. This is already the space. This is already talking about space. The space time. It's in the vacuum. How could this happen? How could have this happened? How could have this quantum fluctuation occurred without space yet? Space did not exist yet. It expanded after the inflation. I could easily look that up right now. It's space-time inflation. Came after the quantum fluctuations, and it's actually called the primordial quantum fluctuations. So we'll scroll down some more. So what drives quantum fluctuation to occur? And this is why I keep telling you guys about this dots and shit. Like, you know, the way the human eyes and the way the human thinks and the brain and these dots really, that's why they connect the dots. They give that to you as a child. This is some hardcore brainwashing technology right here. This right here is a brainwashing as well. Let's envision, let's go over this. What drives quantum fluctuations to occur? Let's envision empty space as a sequence of bubbles. Does that make sense? Okay, if it's empty, why would there be bubbles in there? That makes no sense. Let's envision empty space, but let's envision it as a sequence of bubbles. Like, what the fuck? A sequence of bubbles that there's something there. It's not empty. Okay, and now if we add energy in this empty space with a photon, and now if, there's that word if, and now if we add energy in this empty space with the photon, then particular bubble which affected most by this energy will oscillate that amount of energy. That's so funny. Did you guys see that? It was oscillating. They were all oscillating. They were oscillating. Okay, and due to this oscillation in the bubble, other bubbles also start oscillating. This is supposed to be empty space, but yeah, there's bubbles and they're oscillating. Oh no! Boom! Oh yeah, Pythagorean black magic going on right here. This is what that is. It's Pythagoreanism right here. When they try to use letters and words and symbols to bedazzle to capture the human imagination, like they're trying to capture my imagination with this. And here's how they do it: with uncertainty. Uncertainty in position. So this right here means you're not certain where you're at. Okay? Can you guys see that? I'm gonna start pointing this out. This factor right here means you don't know where the fuck you're at. It says right there, you're uncertain where the fuck you're at. Uncertainty of momentum. That means you don't know where the fuck you're going or even if you're moving. Okay? We already know Planck's constant. Okay? And why would Planck's constant be divided by pi? That doesn't even... Why would you bring that up? What does that have to do with you being uncertain about where you're at or where you're going? This is not confusing me. It's me now showing this has nothing this is not even relative to a quantum fluctuation. What the fuck does that have to do with a quantum fluctuation? Not a goddamn thing. Okay? So there's another version. Since this doesn't work, there's another one. Uncertainty and energy. You don't know what the fuck, you don't know what you're made of. You don't know how strong you are, you don't know how weak you are, you don't know your limitations. You don't know what day it is, you don't know where like the future, the past, you're just stupid. That's what this is saying. Uncertainty of time. There they go with Planck's constant again. I'll tell you guys what, that Planck, like I know all about Planck because he had everything. He has a lot to do with electromagnetic theory, and this Planck constant has nothing to do with any of this. Neither does pi. The fuck does pi have to do with any of this? Pi, you're in a circle, but you don't know what time. You don't know what you're made of. You don't know. It's like, it's just dumb. It's like, just dumb. None of that made sense. And here they go. And so there is another version of the uncertainty principle. There's a lot of versions of not being certain. You gotta be stupid and fucking put faith in this. These fluctuations in the energy in the vacuum become vacuum energy. I know how a vacuum works. I vacuumed out my truck today. That energy took electricity. Because vacuum takes electricity to work. Oh my God. Black, holy shit. So in this way, we can say that energy exists in the vacuum without any particles. And this concept can be proven through mathematics. But, of course, using bubbles. You gotta envision bubbles. Okay? And then you gotta envision that those bubbles are uncertain about their position, their momentum, their energy, and their time. They're just stupid bubbles. And then they have the Casimir effect. Which is basically static. Then you have the role of quantum fluctuations in Hawking radiation. There they go with Hawking radiation. No one's seen no damn Hawking radiation. And so yeah, this all started with like so this all came from, of course we already know, a priest. It came from a priest. Right? And like how would the church stop science? Like how would they do it? Like you can't stop science. They infiltrated science and made science look really stupid. And everyone's running around saying stupid stuff. Totally destroying science. The real life science is being destroyed because people are running around saying really, really dumb things. And like, well, I see they start with these cartoons. Let's go on this one. This is Forbes. So on a macroscopic level, the universe appears to be entirely classical. That means Newtonian. That means static. So gravity can be described by the curvature of space according to the rules of general relativity. Electromagnetic effects are perfectly well described by Maxwell's equation. So here's one thing. Okay, gravity is not part of the standard model. Basically, that's what they said right there. That gravity is not part of the standard model, and it is not a force. It's so they're like the standard model has three. There's three forces, and then they try to add the gravity on the side. But as we've seen already, there's just too many deviations and too many varieties of theories for a justification as to why objects don't fly off a spinning ball. So let's keep going. On ultra tiny scales, do quantum effects begin to come into play, showing themselves in features like atomic transitions, absorption and emission lines, the polarization of light, and vacuum birefringence. And yet, if we try to extrapolate Back to the earliest stages of the universe, every relevant interaction that occurred was purely quantum in nature. Individual quantum particles and fields interacted on short scales. Like, how would they know this? This is all speculation. And there they go with those dots again. And there they go with billions and billions using numbers to try to confuse you. So it started soft good, and then all of a sudden they start talking about, like something that they've never seen. Look, if we want to look back in time, all we have to do is look at the universe as it appeared at greater and greater distances from us. That's insane. If you want to look back in time, you just look behind yourself. Like that's what they're saying. All we have to do is look to the universe as it appeared at greater and greater distances from. So if you start talking about the Big Bang, the way it looks at the model, so that means you're looking behind you. I don't know what they're talking about, because I mean I could run like a whole 3 blocks and look behind myself. I'm not gonna look back in the time. I'm only gonna see so far behind myself. So because light only travels at a finite speed. See, that's another claim. What do you mean, like, light only travels at a finite speed? What finite speed is this? What light are you talking about? There's different lights. There's different frequencies. Some light we don't even see. There's light we can't see with our eyes. So the light we see today that arrives after the journey from 1 billion corresponds to the light that was emitted a billion years ago. A billion years closer to the Big Bang. So light came from the Big Bang. That's funny. When we look in this fashion, we not only see that individual galaxies evolved growing larger, more massive, and redder overall in color, but that the universe as a whole has grown clumpier, more clustered. That's a hardcore. Like these claims are just are beyond like reasonable thought. Like, what do you mean that the universe has grown? How long has humanity been here? According to your billions and billions and billions and billions and billions and billions of years, we're not even if that number is true, that you're like, oh, all these billions of years, then humanity is not even a fraction of 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 a fraction. What we are observing would be only a fraction of 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 a fraction, as we are meant to have supposedly existed. We cannot conclude what our observation would actually be in a billion years or before what we see right now. We can only see what we see now. That makes no sense at all. So this is like, as we can see, this is all speculation, hypothetical. You making this up. Although our universe might seem to be practically uniform on large cosmic scales, particularly at early times, there must have been initially overdense and underdense regions in order to enable this cosmic web to form. So in order for this to happen, something must have happened that we never seen. And look at these dots. So look, we're gonna get ready to end this. Here we go. So we have Albert Einstein's quotes. All right, he's behind a lot of all this, and he left. Believe it or not, I would love to sit here and say that he was a total dick, but he actually wasn't. If you start reading what he said after seeing all this, you start to get what he was saying. All right, there's like a bunch of quotes, that you can go over them yourselves. All right, there's a bunch of quotes that he said, and I like these. So here, two things are infinite: the universe and human stupidity. And I'm not sure about the universe. This is what he's saying. These are his words. Okay. There are only two ways to live your life. One is as though nothing is a miracle. Okay? Nothing is a miracle. We're talking about this nothingness of space, You know how space time, like it popped out of it. The other is as though everything is a miracle. His duality was hardcore. Everything about him was like hardcore duality. Did you guys get that? There are only two ways to live your life. One is as though nothing is a miracle. The other is as though everything is a miracle. He was telling us that the church had overtaken science. I am enough of an artist to draw freely upon my imagination. Imagination is more important than knowledge. Knowledge is limited. Imagination encircles the world. Imagination, the globe. Like they were saying things to us. Like, okay. If you can't explain it to a 6-year-old, you don't understand it yourself. Like these are like simple things. This is my favorite one. This is my favorite one. Okay, and you guys can go back 5 years, 6 years from now. I'll tell you guys about the dice and what Albert Einstein and the dice. I made memes about this stuff, but this was my favorite one. If you want your children to be intelligent, read them fairy tales. If you want them to be more intelligent, read them more fairy tales. Okay, what do you guys think he meant by that? My perspective of and my interpretation of that is that if you taught your kids enough fairy tales and taught them that those fairy tales were not actually believable, they would grow up to see through the bullshit that he was part of and had to spread. Obviously, it seems like he had some type of, you know, problem with his conscience and shit. His conscience was bothering him. But he was telling, I mean, this whole space-time curvature and all that, space-time talking to matter, matter talking to space-time, stuff popping in and out of existence, bubbles in an empty space, and a quantum fluctuation, starting space when it's supposed to be itself within space. Total contradiction. Like it just goes on and on. Priest George Lemaitre was part of this. You know, I could go on. I've already explained how Newton was part of was a Catholic, and the hardcore Catholic was trying to, do his own, subsect of the Catholic Church, and I could just go on and on. And at this point, he was telling us right here: if you want your children to be intelligent, tell them fairy tales. If you want them to be more intelligent, tell them more fairy tales. He said it twice for a reason. Now you tell them one fairy tale, and then that same story, there's a bunch of versions of Goldilocks and the bears. There's a bunch of different stories of Pinocchio. Like there's a bunch of Peter Pan. That's a great one. There's a bunch of different Peter Pan stories. There's a bunch of different gravities. There's a bunch of different gods. There's a bunch of different devils. There's a bunch of